Hi, I am Adam, and today I have Brittany, research analyst at Future Market Insights. We will be discussing on industrial wastewater treatment chemical market.
Hi, Adam. Great to be here. Yeah, it's a topic that doesn't often make the front page,
Right.
but it's so incredibly vital. It's really one of those foundational sectors. It quietly supports global compliance, sustainability, responsible industry. Without these chemicals, honestly, a lot of industries just couldn't operate in an environmentally sound way. They really are the unseen heroes, kind of safeguarding our planet's most vital resource, water.
That's a great way to frame it, the unseen heroes. Okay, so let's unpack this a bit. When we say industrial wastewater treatment chemicals, what exactly are we talking about? I mean, things like coagulants, biocides.
Exactly. Coagulants, flocculants, biocides, anti-scalants, pH adjusters. It's quite a spectrum.
Right, and these aren't just like generic chemicals.
No, not at all. They're really an indispensable toolkit.
Yeah.
They form the backbone for how industries can safely discharge water after they've used it, or, maybe even more importantly now, how they can recycle and reuse it.
That reuse aspect feels increasingly critical,
Absolutely.
especially when you think about the sheer volume of water used in, say, manufacturing or power generation, even food processing. It's huge. So these chemicals are what make it possible to treat that water, make it safe to go back into the environment or maybe back into the process itself.
Precisely. And the application is just incredibly broad. Oil and gas, pharma, chemicals manufacturing, pulp and paper, textiles, you name it,
Basically, any industry using water in its process.
pretty much. Cooling, processing, cleaning, they all rely on these treatments. Without them, effective pollution control is, well, it's almost impossible. The environmental damage, the public health risks, they'd be catastrophic.
And industrial wastewater isn't simple, right? It can have all sorts of nasty stuff in it.
Oh, absolutely. It can be a real cocktail.
Huh.
Heavy metals, suspended solids, tricky organic pollutants, you name it. That complexity really demands a precise and effective chemical toolkit. You can't just throw one thing at it.
Makes sense. So, given how essential this is, let's talk scale. How big is this market we're discussing?
Future Market Insights puts the current estimate at USD 16.2 billion in 2025. That's already substantial.
It really is.
And the projection, it's expected to grow significantly, reaching USD 28.5 billion by 2035.
Wow. That's a big jump.
It's a huge leap, isn't it? It
Yeah.
shows a massive surge in investment.
Yeah, that trajectory is quite remarkable. If you put that into context, that's a compound annual growth rate, a CAGR, of 5.8% over the decade.
5.8%.
And for a market like this, one that's so, operationally essential, it's not just a fad, it's a core requirement. That kind of consistent, robust growth is really quite impressive.
This is not just about economies growing, it's something more fundamental. Exactly. It signals this really deep-seated, expanding need. It goes beyond just ticking boxes for compliance. It reflects, I think, a real global commitment driven by necessity, by public pressure towards much better environmental stewardship. It shows how seriously industries are finally taking their water footprint.
Okay, so we get the scale. Now let's dive a bit deeper, maybe look under the hood. What are the specific chemical categories doing the heavy lifting here? You mentioned coagulants and flocculants earlier. The research shows they're leading the pack, right? Making up around 40% of the market.
That's right, they're the workhorses.
And their job is basically to clump tiny particles together, make them easier to pull out of the water.
Precisely. They neutralize the charges on those microscopic bits suspended in the water, letting them clump together into larger, heavier flocks.
Yeah.
Then, yeah, much easier to remove through settling or filtering.
Got it. But it's not just about clumping things up. What else is in this toolkit?
Oh, there's a whole range of other critical players. Each has a very distinct but equally important role. Well, you've got disinfectants and biocides, absolutely vital for killing harmful microbes, bacteria, algae, preventing biological growth in the systems, which can cause all sorts of problems like fouling.
Okay, hygiene control, basically.
In a way, yes. Then there are pH adjusters, super important. They make sure the water isn't too acidic or too alkaline.
Why does that matter so much?
Two main reasons. One, it helps the other chemical treatments work more efficiently. Two, you have strict limits on the pH of water you discharge back into rivers or lakes to protect aquatic life.
Right, makes sense. What else?
Corrosion inhibitors and anti-scalants. Can't forget those.
Okay, protecting the pipes and equipment.
Exactly. Corrosion inhibitors protect all that expensive industrial gear from breaking down, and anti-scalants, they stop mineral deposits scale from building up inside pipes and on surfaces.
Which would clog everything up and reduce efficiency, I imagine.
Absolutely.
Yeah.
Clogged pipes reduce heat transfer, big operational headaches. So yeah, each of these chemicals is a key piece in this complex water treatment puzzle.
And it's not static, is it? The chemicals themselves are evolving.
Definitely. There's a huge emphasis now on what's called precision dosing,
Meaning?
using smart systems, sensors, analytics
Yeah.
to add exactly the right amount of chemical at exactly the right time. No more, no less.
For better results and less waste.
Precisely. Improves effectiveness dramatically, cuts down on chemical waste, saves money. It's a win-win.
And I guess there's a push for greener chemicals, too.
Oh, absolutely. A really strong push towards biodegradable formulas, eco-friendly compositions. It's not just greenwashing. It reflects a real shift in environmental consciousness across the industry, moving away from older, potentially problematic chemicals towards solutions that are effective but also kinder to the environment overall.
That's encouraging. So we have this vital market, impressive growth, evolving tech. It brings us back to the why.
The million-dollar question, right? What's really driving this consistent, accelerating demand?
Well, from everything I've read, the single biggest driver seems clear: tightening environmental regulations all around the world.
It's hard to argue with that one.
Governments are just getting much stricter, higher standards for wastewater discharge. And these aren't suggestions, they're legal requirements. Big penalties, fines, even shutdowns if companies don't comply. So companies have to invest in these chemicals just to stay in business, essentially.
Regulation is definitely a massive force, no doubt. But it's not the only pressure point.
Okay.
Think about other huge global trends converging. Rapid urbanization, ongoing industrial expansion, and maybe most critically, increasing water scarcity.
Right, the water stress issue.
Exactly. More
Yeah.
people, more industry.
Yeah.
Means more demand for water. But the freshwater supply isn't keeping up, is it? Climate change, over-extraction.
So that forces industries to think about reusing water.
It creates immense pressure to reuse and recycle wherever possible. And if you're going to reuse water effectively and safely, you often need more advanced, more effective treatment, more sophisticated chemicals. It becomes a kind of self-reinforcing cycle.
So it's moving beyond just compliance. It's
Okay.
becoming strategic.
Precisely. It's becoming a strategic imperative. It's about long-term sustainability, operational resilience.
Companies are realizing that managing water efficiently using these chemicals isn't just about avoiding fines. It's essential for their operations, their public image, their social license to operate.
Absolutely. It's shifting from being just a cost center to being a critical investment in their future, a non-negotiable part of corporate responsibility now.
Okay, that makes a lot of sense. Let's
Yeah.
talk geography for a second. Where is this growth strongest? Are there particular hotspots?
Yeah, looking at regional growth is quite revealing. The UK, for example, shows a pretty significant projected CGR, 7.8% between 2025 and 2035.
Wow, that's quite a bit higher than the global average you mentioned. Why so high in the UK?
It suggests more than just a robust regulatory environment, though that's surely part of it. It could point to a really concentrated push towards industrial modernization, maybe specific targets for water circularity in key sectors, a more proactive approach perhaps.
Interesting. And what about other major regions? Asia-Pacific must be huge given the industrial growth there.
Oh, absolutely. Asia-Pacific continues to see rapid growth, massive infrastructure development, relentless industrialization. As new factories and plants come online, the demand for basic services like wastewater treatment just skyrockets. It's directly linked.
Makes sense. And North America, still a strong market.
Very much so. North America remains a strong, mature market. You see consistently high demand, especially in industries like oil refining, pulp and paper, food processing, places with really complex waste streams, and frankly, exceptionally stringent environmental standards already in place.
So the established regulations there keep demand high for sophisticated solutions.
Exactly. Those mature regulatory frameworks ensure continued investment. It remains a really significant, reliable growth region.
So who are the companies actually leading the charge here, innovating and supplying these crucial chemicals? On a regional level, the research mentions names like Heubach, India, DIC Corporation, Clariant, Sudarshan Chemicals, Sun Chemical, ADD Chem Germany, Jet Color.
Yeah, those are important regional players, often very good at tailoring solutions to specific local conditions and rules, which is vital.
And then the global giants.
Right. You have companies like Kemira, Veolia, Ecolab. These are massive players, and they're investing heavily, not just producing chemicals, but driving innovation and sustainability.
What kind of innovation are we talking about?
All sorts. New chemical formulations that are more effective or greener, advanced monitoring tech, low toxicity, biodegradable options, and a really exciting area is AI-optimized dosing.
AI. How does that work in wastewater?
Basically using AI to analyze real-time water quality data flow rates, pollutant levels, pH, everything, and then precisely controlling the chemical dosing.
To maximize efficiency and minimize waste.
Exactly. Maximize efficiency, cut chemical use, reduce environmental impact.
Yeah.
It's a real game changer. Moving treatment from reactive to predictive and optimized.
That's fascinating. So looking ahead then, over the next decade or so, what are the big trends we should expect to see shaping this market?
Well, building on what we just discussed, definitely continued and I'd say accelerated adoption of those smart chemical dosing systems. Sensors, automation, driving accuracy way up, costs way down.
And real-time monitoring becoming standard.
Absolutely. Giving operators instant feedback, allowing for much quicker adjustments. And alongside that tech push, I predict significant growth in green chemistry formulations.
More environmentally friendly options?
Yes, solutions designed from the ground up to be less hazardous. The focus won't just be on the treated water, but on the impact of the treatment chemicals themselves.
That seems crucial. And what about new challenges? Are there emerging problems these chemicals will need to tackle? One thing that comes up a lot is emerging pollutants, specifically things like PFAS, those per and polyfluoroalkyl substances, the forever chemicals.
Ah, yes, PFAS. A huge challenge.
Because they're so persistent and hard to break down, right? So we can expect demand for specialized treatments for those to surge.
Without a doubt. Removing PFAS is incredibly difficult. It requires highly specialized, often novel chemical approaches. That's going to be a major area of R&D and market growth.
So summing up the future outlook, it sounds remarkably stable, increasingly tech-driven, and very focused on sustainability.
I think that's a fair assessment. It really underlines that responsible water management isn't just, a nice to have anymore. It's a core business principle for industry.
Yeah, it feels non-negotiable now.
So to kind of pull it all together, what we've talked about today really highlights a market that, yeah, it operates mostly behind the scenes, but it's quietly providing this powerful support for crucial environmental efforts globally. It's truly a foundational piece of our industrial infrastructure.
And its growth shows that industries really get it now. Sustainable water management isn't just about compliance anymore. It's fundamental to being a responsible business, to building long-term resilience. And this chemical market is right there, providing the tools they need.
Well said. It's a sign of how our whole relationship with industrial water use is transforming. To explore more insights like these and to dive deeper into high-impact markets, be sure to visit Future Market Insights for more information.
And for continuous updates and interesting analyses, follow Future Market Insights on LinkedIn. That's it from us today. Until next time, stay hydrated and stay curious. Bye, everyone.